how are you guys doing? It's kind of, after lunch food coma zone, but I was pretty impressed with that they managed to feed 1,800 people, in one room. It's like a feat to orchestrate, for sure. So you guys having fun at the conference so far? Awesome. All right, we got like 45 seconds. Try and start on time. All right, it's officially 1 o'clock, so I'm going to start now. But hi, everyone, and welcome, and thanks for coming. This talk is on top 5 reasons why improvement efforts fail. And rather than telling you about all the grand, amazing things I've done in my career, I'm going to tell you about all my biggest failures, what I learned from them, and how my beliefs have changed over the years. So lots of stories about screwing things up really horribly, going terribly wrong, and them not seeming like they can get any worse, and then them getting worse. So quickly introduce myself. My name is Janelle Klein. I've been a developer for about 15 years, did consulting for about 5 years, and now I'm CTO at New Iron, a software niche recruiting company that specializes in technical assessment and developer mentorship. So my job is kind of weird. I basically teach people for a living and coach developers in the art of software development. So for the last 5 years, I've been working on this book, Idea Flow Learning Framework, which I just finished last week, so I'm really excited about that after 5 years of pain. But essentially, it's a data-driven process for software mastery. So you'll hear a bit more about this during the course of this talk. A lot of the ideas and things I've learned over the course of the years basically been dumping systematically into this book. So this talk centered on the question, why is visibility critical to success? Why do we need data to know what are the things that we ought to improve as opposed to just relying on gut feel? So this is the primary reason of why improvement efforts fail. So as I promised, I'm going to start this talk with stories of failure. So first, let me tell you about my story here. So I was on this project. This was about 8 years ago. And we were trying to do all the right things. Had CI, unit testing, design reviews, code reviews, all that stuff you're supposed to do, right? So I had been on the project about 6 months. We were doing final testing for a major release, tied a bow on it, and shipped it to production. I should mention, it was a factory automation system for semiconductor. So our system was responsible for detecting all the things that went wrong in the factory and then shutting down the tools responsible when something went wrong in the manufacturing process. So anyway, we shipped it to production. And later that night, we were on this conference call with IT. And I hear this guy just screaming in the background. And apparently, we had shut down every single tool in the entire factory. So we rolled back the release and tried to figure out what happened. And there was this configuration change that didn't quite make it to production. So we fixed the configuration change, and we all felt terrible, but there's not much we could do at that point. So, fix the bug and ship to production again. Back on the conference call with IT, and guess what? Same thing happened. Every single tool in the entire factory completely shut down. So if you imagine semiconductor, so you've got this big giant factory making semiconductor chips, and every single tool, these guys do like 50,000 wafer starts a day, and the entire place was like shut down, right? So once again, rolled back the software and tried to figure out what happened. But we couldn't reproduce the problem. We actually spent months trying to figure it out, and like there was nothing we could do to make the system behave the same way in development. And meanwhile, our development team was sitting pretty much idle, so management just told them to go ahead with the next release. And everyone was acting like nothing was wrong, but we couldn't ship anything, right? And a few months later, we eventually figured it out, and there was this logging statement that was added that happened to be in some multi-threaded code, and the logging statement happened to call a synchronized block that ended up snowballing the entire system. But we needed realistic data stream to actually produce the specific characteristics that made the thing explode, even though it happened every time in production. So, fixed the problem, crossed our fingers, and shipped to production again. Back on the conference call with IT. And this time, there's a whole room full of people, and we're all looking at these real-time activity charts and holding our breath. And finally, everything looked okay. So we went home that night thinking everything was going to be fine. And then about 3 a.m., my phone rang. And it was my team lead calling. And he asked me about some code that I'd written. And I'd done some refactoring work to improve the code and make some things better, do some performance improvements, make the design better. And I accidentally introduced a memory leak that ground the system once again to a screeching halt. And so my team lead's asking me about the code, and I'm looking at it on my laptop, and I'm like, aha, I added a feature toggle. And I told him about the feature toggle and that we could turn the feature toggle off to disable it. But the feature toggle failed. And the log started filling with null pointer exceptions. So then I'm like, okay, well, let's roll back the release. So he runs the rollback script, and then the rollback fails, right? So imagine everything completely down, and we can't get our software out of production, and it's all my fault. So you can imagine how horrible I felt while I was up at 3 a.m. coding up, a fix to get this thing out of production, right? I felt pretty horrible. So I got the code patched, we got it in production, got the system running again. But then I had to go to work the next day. And my boss calls me into his office, and he's like, what happened? And I just completely broke down in tears. I was just sitting there sobbing. And he's like, you've got two choices. You can put it behind you and try to let it go, or you can face your failure with courage and learn everything that it has to teach you. And I really took that message to heart. So I went back to my team, and I was like, okay, let's work together and see if we can figure this out. And that, all the things we were trying to do to prevent these kind of problems with best practices weren't working effectively. All the things we thought were the right things to do weren't leading us to success. We brought down production 3 times in a row. So what do you do at that point? Well, you got to figure out what your problems actually are, right? So I thought the main obstacle was technical debt that was building up in the code base and causing us to make mistakes. So I wrote this tool that could detect high-risk changes and let us know where we needed to do extra testing. But what I found wasn't what I expected at all, and that most of our mistakes were actually in the most well-written parts of the code. So that was kind of confusing, but one thing I did find was this. We made significantly more mistakes in the code that we didn't write ourselves. And that made some sense. I mean, you're working with things that you're not as familiar with, you're going to make more mistakes, but it seemed like there had to be more to the story than this. I mean, this is what I knew. When I had to work with complex code, it felt really painful, right? But what made development actually feel painful? So I started keeping track of my painful interaction with the code and visualizing it on a timeline like this. So the pain started when I ran into some unexpected behavior and ended when the problem was resolved. So this is like 5 hours and 18 minutes of troubleshooting. Would all of you agree that's pretty painful? So this is how I started to think about pain in software development. And if I wanted to understand the causes of pain, I needed to understand the things that that drove these type of problems. So I started breaking down the pain by likeliness of unexpected behavior and the cost to troubleshoot and repair the problems. And then breaking these things down into categories. I started categorizing mistakes of all different types and categorizing problems of troubleshooting. And what I found was most of the problems were actually caused by human factors, as opposed to the things we normally think of like technical debt. So for example, stale memory mistakes. So this is when I have an idea in my head about how the code works, but somebody changed it and it doesn't work that way anymore. It's not a problem with technical debt, it's a problem with being human. Humans make things really complicated. Or likewise, ambiguous clues. So this is when you're running an experiment and you get feedback for something and there's more than one possible way that that particular behavior could occur, and you make a bad assumption and down the rabbit hole you go. You know, the clue coming back from the test is ambiguous. It's not something kind of inherent to like that we think of as technical debt. It has to do with the design of how we interact with the code. Does that make sense? So what I got from this is that pain occurs during this process of understanding and extending the software when we're interacting with the code. So I started focusing on optimizing developer experience as opposed to optimizing the code. And what I realized is all that time that we spent working on improvements, as we were steadily working on improvements and best practices and trying to make things better, we were trying to improve, but we weren't actually solving the right problems. And the worst part about this is we didn't even realize that our improvements weren't actually effective. There was no real feedback loop, right? We just kind of do things that we think are supposed to make things better and follow best practices and do unit testing and try and write modular code. But how do we know if all those things are actually making things better? So it took us 2 years to turn this project around. And we did it without starting over. I mean, it was a 10-year-old code base. Starting over wasn't really an option. So then when I got into consulting, I saw a lot of the same exact patterns I ran into on this project, in that builds were breaking and releases were painful, productivity was slowing to crawl, and all these projects were in so much pain. And then the teams believed that the problem was these problems that were building up in the code that were causing this pain. And so they'd brainstorm a list of all the problems and fill their backlog, make a technical debt backlog with all of their improvements. But they ran into essentially the same problem, that the improvements didn't end up making much difference. So this talk is about why this happens. Why we can spend so much time working on making things better and not actually solve our problems. So top 5 reasons improvements fail. How we end up in this state of fixing the wrong things. So first one, we assume best practices will solve the problem. So here's what my team did. So our regression cycle was taking about 3 to 4 weeks. It was a 10-year-old project, had this big pile of manual tests that we'd written over the years. And so we thought, hey, let's automate the test. That's the right best practice thing to do, right? So we started working on automation and, chipping away at all the automated tests. But maintenance started to get really painful. And so we thought, hey, well, maintenance is painful. What do you do when maintenance is painful? You make things more maintainable. So we started working on refactoring the tests. But the problem was that despite all our effort in refactoring, the tests were still really painful. And it was a morning at one of our stand-ups, and one of my teammates was complaining about how ridiculously painful all these tests were to update. And he's like, well, at least our regression cycle is faster now, right? And we were all just stopped in our tracks and looked at each other and go, our regression cycle is still taking about 3 to 4 weeks. And we've been working on this automation effort for like a year. A year has gone by since we started this whole effort and built this whole mountain of automation. And we didn't even solve the original problem that we set out to solve. And what I discovered in this is that a regression cycle was taken up mostly by time diagnosing bugs that were coming up, and that most of our bugs were discovered with exploratory testing. So all these tests, we spent all this time automating, wasn't actually helping us solve the problem at all. We completely missed the boat because we didn't understand what our problem was. So we ended up deleting everything because the automation wasn't actually solving our problem. So what did we do instead? How did we end up solving the quality problem? So we started by asking, what are the risks in this release that we're about to ship right now? And how can we mitigate those risks? And so we took a handful of our manual tests and we'd run those, and then we started building custom tools specifically to mitigate the test for that specific release. So we ended up with all kinds of automation, but it was very different automation because it was very focused on solving particular problems. So one of the things that we found was causing a whole lot of our excessive costs was rushing at the end of a deadline. So once your problems get really kind of crazy and unpredictable and the work gets really hard, there's this effect gets exacerbated, but essentially you've got, the sprint boundary, right? And then everybody rushes at the end of the sprint boundary. And then as soon as you rush, you end up with, all these things that don't get tested adequately, that get found in QA or later in production. And the more we spent time rushing, it caused this like order of magnitude cost increase in troubleshooting. And so we ended up switching to fixed scope as small as possible releases to get around this whole deadline effect and get control over our problems. And that just, test it and do, we'd come up with a risk mitigation strategy, and we were done and ready to ship a release when we were done mitigating the risk. And so this is how we ultimately ended up turning the project around. And we regained control over quality by dropping the deadlines, and we had this great decline in our defects as a result. But the point here is sometimes best practices can be the cause of your problems. And on new projects, there's plenty of other reasons to have deadlines too. I'm not saying that we shouldn't do fixed time boxes, but there's consequences and side effects too that are very obvious when you start measuring the data. So the question here is really, what target are we trying to aim for? What does better really mean? So a lot of times when we talk about better, it really means better following best practices. It's very kind of solution focused. But what we really need it to mean is better solving the problems. And so when we focus on better following best practices, we tend to start with the solution. We've got our hammer in hand and we're looking for the nails. Whereas with better solving the problems, first we start with the problem, figure out what nail we're trying to affect, and then we choose the right hammer. And so what I see a lot in teams is this sort of solution-oriented problems where, we'll be in a retrospective and we're looking at what are the biggest problems that we need to solve, and we end up with something like, well, the problem is that we don't have enough test automation. And this is essentially a solution masking itself as a problem, right? But this happens a lot when we get in that best practices mindset of not having best practices becomes the problem that we're trying to solve. So one of the things that causes improvements to fail or the lesson learned from that is focusing on the nails, understanding what is the root problem that you're actually trying to solve, and then finding an appropriate solution that goes with it. So ask yourself, what problem am I trying to solve? Make sense? Okay. So broken target. All right, so next one. So we assume the biggest problems will come to mind. So again, here's kind of what my team did. We got in a retrospective meeting, and our Scrum Master asked, what's the biggest opportunity for improvement? And we had all kinds of ideas, like the awful email template engine code, and fill in missing unit tests, and I know how to improve database performance, and let's improve maintainability of our test framework. And what I learned is, none of these things look like bad improvement ideas on the covers, right? Nothing wrong with these ideas. But just because a problem comes to mind doesn't mean it's an important problem to solve. And what I learned after doing some reading in cognitive science space is when we're asked a complex question like this, like what's the biggest opportunity for improvement, and we don't readily have a sophisticated answer, we actually substitute that question with a different question. And what we're actually asking ourselves is, what do I feel the most intensely about? And those are the things the answers that end up coming to mind. And what happens when we're thinking about the intensity of our feelings is bias has a huge play in the things that come to mind for improvements. So for example, recency bias. The things that bothered us most recently more readily come to mind. Or guilt bias. If you've ever felt shamed for not writing those unit tests you're supposed to do and feel guilty, you want that to be up on the improvement list. Or known solution bias. We tend to want to solve problems we know how to solve as opposed to problems that we don't. Or sunk cost bias. Like we had this test framework that we'd already sunk, almost a year into and had all these maintenance problems. So we wanted to fix that just because, even though it wasn't effective, because we'd already dumped and invested so much of our time into it. And one of the biggest reasons I've found that our ideas on improvement are a lot of times way off is that our perception of time is way off. So if you think about when you're troubleshooting problems and you're kind of running experiments to figure out what's going on, you have time that you spend setting up the experiment and time that you spend executing the experiment, and then you analyze the results and decide what you're going to do next. And when we're executing things, we're waiting. And time goes really slowly when you're waiting for things to happen, right? But when you're doing stuff, time kind of zooms by. So have you ever been focused on troubleshooting a problem all day long and you're just into the code and what's going on, and then you look up and the entire day has just totally gone by? I mean, this is why our time is so skewed, our perception of time. And so when we're thinking about what actually takes a long time during development, we're biased to look at problems in execution time and not necessarily pay attention to all these human factors that have hugely dominate the amount of time that we spend. So once I started focusing on these human factors in software development and designing kind of the code and around optimizing developer experience, I was able to drastically reduce troubleshooting time just by focusing on those things instead. So relying on gut feel is one of the common reasons we end up in this situation. So our gut feel basically ends up way off. So to solve this problem, I install a pain sensor in it. So, by the way, I do all my own artwork for my slides. This is what turned into my art career, turned into drawing robots with burning hands and stuff. So, still get to use my skills that way. Anyway, so as I mentioned earlier, pain occurs during the process of understanding and extending the software. So this process didn't really have a name, so I started calling it idea flow. So idea flow is the flow of ideas between the developer and the software. So if you imagine I've got an idea in my head, and as I'm coding, I'm trying to kind of communicate that idea and move that idea into the software, kind of molding the code like clay to represent the idea in my mind. Or if there's an idea represented in the software, I'm trying to understand it and get that idea kind of in my head. So you can imagine this flow of ideas between the developer and the software. And friction in developer experience is the stuff that gets in the way of that flow. So this is what I'm calling friction in idea flow, this time that we spend trying to understand stuff and trying to troubleshoot stuff to figure out how it works. It's friction in that process of understanding. So there's 3 types of friction that I started measuring: troubleshooting, learning, and rework. And so the way I've been doing this is I've got these tools that integrate with your IDE, and they're not complicated. They've got 3 buttons for troubleshooting, learning, and rework, and what your active task is you're working on. And they basically just record this data while you're doing development. So in some case studies, so this is a healthy project, about 10 months old, and where we actively focused on reducing troubleshooting time. And even with all of our time focused on this, just with normal problem-solving challenges, about 10 to 20% of our time was spent on friction. So this has become my baseline for what healthy looks like. By contrast, a second case study, this is a 18-month after a rewrite effort. So monolith application, kind of the same story we heard about this morning in the keynote, but they had a big monolith application, big hairball, and they ended up essentially creating a distributed hairball, right? And 18 months into a big microservices rewrite with continuous delivery, and all that good stuff, right? Spent a lot of time working on unit testing automation. And 18 months in, they were already spending about 40 to 60% of their time troubleshooting problems. And so the team noticeably started slowing down. And so management said, okay, we hear you about all the problems and technical debt. We'll give you 3 months to work on solving these problems. And the team was focused on reducing the technical debt and all the microservices code. But this wasn't their biggest problem at all. And then I got there after this, and integration problems across the teams that led to environment downtime were costing them 1,000 hours a month. And none of their improvements solved this problem at all. And I think this is one of the things you see happening in microservices is once it's distributed and cross teams and you get the architecture wrong, it becomes really challenging to deal with the cross team issues, much more so than if you just had one application where everybody could fix things. So it's like we need to have, once we distribute, we need to have a process to learn and adapt the architecture. And that it always looks good on paper, right? Until you actually go and try and put things in practice and stuff changes and adapts. But because they had this pressure to hit feature parity, and there's so much business pressure to keep on going and keep on trucking through, they ended up in this situation where half of their time was spent troubleshooting problems, and they couldn't slow down. So another case study, this is a 12-year-old project that was inherited by a team. All the original developers had left. So this is what it looks like when you spend 90% of your time figuring out what to do and 10% of the time actually doing stuff. So if you've ever worked on a project that you had no familiarity with all, losing developers on a project is a big deal. But when it comes to headcount and what managers see from the outside, all of this is invisible, right? So the team's focus in this case, they were trying to increase unit test coverage by 5%. But once we started measuring the data and figuring out what the problems were, generating test data for running reporting engine experiments was costing them 700 hours a month. Wasn't on their improvement list at all. Not at all. And until we actually started adding these things up, you can't really see it because it's nickel and dime all over the place. And until you start aggregating the data, you just don't see it. So why measure friction? So I wanted to show you too that all 3 of these case studies, all of these tasks are 1 to 3 day tasks. And that there's always things that are small. Even when you have horrendous problems, you just keep chunking down the work size into manageable chunks. And so even though you can see quality problems and a lot of these things from the outside, we can't really see this buildup of problems over time by measuring velocity or task lead time. It just doesn't show up in the data. There's so much variability from normal noise, you can't see it. But if you measure what's going on the inside, it's obvious there's this buildup of pain. So visibility lets us add up all that distributed pain so we can see what our top 3 problems are that are actually costing us time and focus on those things. So broken visibility. Another reason we end up improving the wrong thing. So lesson learned here was install a pain sensor. And on my project, before we had all these tools, we basically just used the whiteboard. And anytime somebody ran into a problem, we'd jot it down on the whiteboard and keep rough track of hours with tallies on, just really rough stuff. And there's a big difference between no data and a little data. What I'm doing now is very high fidelity, but it's not strictly necessary to be able to kind of have that adjustment of being able to find out what your biggest problems are. So ask yourself, how do I know the right improvements are on the list? Because it's really easy to end up with a list of things that aren't actually your biggest problems. All right, so broken visibility. Any questions about that? You guys are all very quiet. Okay. So next one, we assume that we understand the problem. So I mentioned before this deadline effect. So once we saw this effect happening in the data, the first thing that we assumed was that, well, if problems are more expensive, if once you cross these boundaries, that developers need to detect mistakes earlier, and that should reduce the pain, right? It's a logical conclusion given this premise. So we started writing lots of tests and, going through the normal automation process where, you got a bug in your code and you write a test to protect against that bug and get rid of the bug. And then over time, you end up with all of these kind of like anti-bug things in here, right? But what kept happening is despite all the automation we had of bug prevention, that we'd always end up with different bugs. We had green bugs instead of the red bugs that we were preventing. And this happened over and over again, that no matter how much bug protection we built up, it was never the right stuff that we needed. So what did we do? So the thing that I learned from this is that we need to stop making generalizations. And that if we start looking at what caused each specific problem and then generalizing from that, what are the patterns of cause and effect with all these specific things, then we end up with making much better conclusions about where we should invest our efforts. What's actually causing people to make mistakes? What's actually making troubleshooting hard? As opposed to generalizing about principles that we should just write more automated tests. Is when we don't actually understand what's causing the problems, it's really easy to write lots of tests that aren't actually effective at solving the problem. So we've started breaking down the dimensions of risk, and as I was mentioning, breaking down these patterns. And then we started tagging the problems by type, and then sorting the problems into buckets. So these are some of the different pain types I use now. So experiment pain, this is problems when you're trying to figure out what's going on and fiddling with things and it being hard to troubleshoot problems. Alarm pain, this is when you've got lots of automated tests that you're constantly having to repair that aren't actually catching bugs in your software, just lots of repair work, which happens a lot of times these days too. Collaboration pain, this is when you have to work with other people, and it's software is so much more difficult because we have this whole team environment where we've got all these different brains that we have to coordinate and work together. It makes it hard. I mean, all kinds of challenges with trade-offs and merging problems and all kinds of things. Cognitive pain, this is when I always say, oh, this hurts my brain. Like there's just so much to think about. It takes a tremendous amount of focus because there's so many details that you have to keep in your head at once. So we started categorizing all of these problems into categories, and then we choose a category to focus on, and then start breaking down the specific problems in that category. So in this case, I've got slow feedback loops and numerous feedback loops, which are caused by totally different kinds of things. So if I've got, for example, non-deterministic behavior, that leads me down as a very different kind of challenge than having a test that runs slow, right? So you've got different kinds of causes for different kinds of problems. So with this, guess what we ended up finding after we broke down all of our problems? Wasn't what we originally expected at all. So remember this? We made significantly more mistakes in the code that we didn't write ourselves. So what we ended up finding was the bugs were actually in our conceptual models and not the code. In that we'd had people turning over on the team, and people had misunderstandings about how different parts of the code worked. And so then when they'd write code, they'd introduce bugs because their conceptual models were wrong. And so to solve this problem, we built a data dictionary. We got around a whiteboard, drew diagrams of the architecture, came up with a standard vocabulary for all the terms and meanings of things, and worked out the kinks and ambiguity, and got the conceptual models clear in everybody's minds across the team, then published documentation and a glossary that we made the ubiquitous language for, across development, requirements, everybody we made basically speak using the same language. And what happened was really fascinating, because not only did the quality of our code and the clarity of our code improve as a result, but we had all these communication problems that went away, and our defect rates plummeted just by spending a little time getting everybody in sync in terms of understanding. Because those problems in understanding, they just keep causing bugs in the code. So the lesson learned here is stop making generalizations. And that generalizations get us in a lot of troubles. We just generalize to a principle, and it seems like the right thing to do, and in general, it is. It's just the devil's always in the details, right? I mean, software development is hard. So ask yourself, what are the specific patterns of cause and effect? Any questions about that? Makes sense? Okay. I'm going to get through these slides early. I got 144 of them, too. All right. So next one. We assume that understanding is enough. So this is a problem I actually ran into in the context of mentorship. So I was teaching this developer, George, and using the same technique, and I taught him about this problem where you change a whole bunch of things at once and end up with a whole mess of troubleshooting problems at the end, right? I call it the Haystack Effect. And so he'd create idea flow maps and come up with idea flow maps that look kind of like this. So there's lots of development work, and then at the end it's like I spent 8 hours doing troubleshooting, right? You guys done this before? So when I was talking to him, I asked him what made troubleshooting take so long, and I realized that he was missing this concept of what I call the Haystack Principle, and that you have lots of unvalidated changes. It's difficult to find the needle in the haystack, and if you have a few changes at once, it's easier to find the needle. So we want to optimize for small, manageable haystacks. You got if you have small haystacks, you get idea flow maps that look like this, where you can actually see the reduction in troubleshooting time. Or if you have big haystacks, you get that skipping tests and validating at the end, having that big problem. So I taught him this principle and showed him how it looked like in developer experience. But no matter what I did, he kept repeating the same mistakes. And that, he'd come back and we'd talk about the exact same thing again, except once he understood, he's like, oh, I know I made a big haystack, I'll do better next time. And he'd say that every single time. And I'm like, okay, what's going wrong here? Why is the lesson and the understanding not enough to get him to change his behavior? And what I realized is this effect of understanding is actually hindsight bias. And it comes up a lot in other contexts too. We believe that we've learned the lesson because we understand what went wrong in that experience, but that doesn't necessarily mean the things that ultimately caused it will change as a result. And that we tend to make autopilot decisions and do what's familiar because we've been coding for years, and our coding has become a habit. And changing our decision habits is not that easy. But how do we break decision habits? Any ideas? What's that? Peer review. It's a great one. I do peer reviews, but a little bit differently, and then I'll show you in just a second. But this is kind of my solution to everything these days. Is we stop and think. It's kind of the same thing Simon was talking about this morning of that we need to start thinking about what we're doing earlier in the process. So if you imagine that your brain is kind of like a decision-making engine that's written in code. And if we stop and think, it's kind of like putting a breakpoint in our decision-making engine. And if you imagine what your thoughts look at that time, it kind of looks like a function. Where you've got inputs that you're considering, you've got logical evaluation that you're doing of those inputs, and then you kind of return a decision from your function. So essentially, in that moment when we're making the decision, we have to predict that we're going to run into a big haystack for anything to actually change. And if we don't predict it in that moment, then we just keep going down the same path. And then after the fact, we realize, oh, that was a dumb thing to do. I shouldn't have done that. And in that same hindsight bias cycle. So I started, I used a couple different books as inspiration from this. The Checklist Manifesto. It's a great book. It comes out of the medical industry. But essentially, this guy came up with this 90-second checklist that ended up cutting down the rate of fatalities by more than a third. And all it was is essentially making sure that we do things like ask people what the weapon was that you got stabbed with. There's this great story in the beginning about this guy in the ER that got stabbed with a bayonet, and they thought he was fine, and he almost bled to death. because nobody asked him what the weapon was, and nobody assumed that he got stabbed with a bayonet and it actually, gone all the way through his body. So, and just simple things like that in that context can save lives. But I started repurposing this to software development and asking, well, what are the things that we need to think about in the moments that we're missing? And it's really a lot of the same kind of challenges. We've got this complex field of all this stuff that we have to think about, and thinking the right thought in the moment is really hard. So I combined these ideas with stuff from Ash Maurya from the Lean Startup side of the community. So they've basically taken a scientific method approach that they've been applying to the business world and figuring out how to run experiments in the context of business, which in a lot of ways is harder than the challenges of running experiments in software development. So I took these two techniques and kind of combined them together and came up with a way to change decision habits. So I've got this problem here. I want to avoid this big haystack. So I'd ask myself, what question could I ask my future self to recognize similar risks like this in the future? And in what situation would I ask the question? And then I come up with a thinking checklist. Is my current approach likely to cause a big haystack? And I want to ask that at the start of a subtask. So I'd actually make physical checklists on paper. And then I'd start pair programming with George here. And so at this moment, we're about to start a subtask. Ask, is my current approach likely to cause a big haystack? You kind of think about your strategy, what you're planning to do, and what your haystacks are going to look like, and go, okay, let me make a prediction. I think I'm going to end up with small haystacks based on my strategy. But the problem is, run into a big haystack anyway. But the circumstances are different, because now that we've kind of set this up as an experiment, this big haystack becomes a false prediction. So now we can start looking at, well, what are all the high-risk situations that cause big haystacks that I didn't think of earlier in those moments, and start making a list. So then I started augmenting these checklists with lists of high-risk situations. So for example, the unraveling sweater problem. If you've ever had a dependency and then you pull on the dependency and there's another dependency behind it, before you know you've got all the code unraveled. I mean, when you're making a change that involves kind of a cascading dependency chain like that, keeping your haystack small is really hard, right? Or having an integration heavy change. Sometimes your code change isn't in the units, it's in the integration space. So even though you do lots of good unit testing, when you get to the end, you're still kind of integrating everything together at the same time and have that same kind of troubleshooting challenge. So there's all these different situations that make this much easier said than done. We can talk about, oh, well, you shouldn't make lots of changes at once. So you should do vertical slices, or, there's all these strategies and tools, but there's a lot of things that make software development extremely hard. And we talk about these principles, but how you actually put those in practice has so much contextual detail. And by putting these things into patterns, we can start sharing our experiences with that contextual detail of what are all these circumstances and different strategies we need in those different situations. So I started basically doing that for different situations, what are the different types of strategies we need to apply, and breaking all these things down into patterns. So with the unraveling sweater problem, for example, if you recognize up front that you're in that situation, you can go, okay, well, let me do some upfront dependency analysis and figure out what that dependency chain looks like so I can come up with a creative way to break it up in pieces. But if you don't stop and think and recognize that situation, you can't choose to do anything differently. Or with the heavy integration logic problem, if I could, instead of writing unit tests, I could write a integration test that I can kind of incrementally add things to so I can get feedback on the integration as I go. So I can use a different type of strategy if I recognize I'm in that different type of situation. Does that make sense? So essentially, this is codifying what works in terms of, I see these nails, and this is the appropriate kind of hammer. So one of the things I realized was best practices, the way we teach best practices, are backwards. And that if you imagine we've got this data structure in our head, we've got this hash map that's indexed by solutions. But we don't encounter solutions. We encounter problems, right? And we essentially need a new data structure. We spend our entire careers contextualizing everything we learn, through development because we teach everything in terms of solutions. You ever seen, I definitely went through this phase myself of reading the design patterns book, and then, it's like, oh, I got all these tools, and then I want to apply them everywhere. You got your hammers, and it's like you have to kind of learn the hard way a lot of times. But I think we need to fundamentally change the way we organize patterns and teach software development to be problem-oriented as opposed to solution-oriented. So lesson learned on this one of another reason why improvements fail is that hindsight bias effect, and that we don't actually change our decisions in the moment. We're not stopping and thinking and making different choices. So ask yourself, when you're looking at a problem, how does my decision making need to change? And then how can I actually affect those changes? What do I need to think about differently in the moment? Questions, thoughts? Yeah. So the question was, how does your graph change when you stop and think, and would those become learning moments, and would the visualization change when you do that? I generally start off with only having people track troubleshooting time, but when I track learning time, if it's something that's fast, I don't bother writing anything down at all. And then if it's something that's like a substantial thing, I'm going to spend a few minutes on or more. Generally speaking, I track learning bands at the start of subtasks. It's like I've got a whole language vocabulary about how to break all this stuff down, but it's a good question. The visualizations are one of those things that was a lot of trial and error of figuring out how should we represent the experience to a degree that helps us talk about it and have a useful conversation. And so there's, you can go and track every single little nitty-gritty detail, but it's not really necessary. Does that answer your question? Yeah. It's a whole nother talk. So talk to me after. Okay, so that's broken awareness. So the last one, we don't make the problems visible to management. So if you've ever been in a typical work environment, you're probably used to this problem, right? Of management just assuming that we can just, I don't know, work as fast as we can and things will be great. And what ends up happening, we get in this environment of constant urgency, and we end up making decisions that are kind of like leaving a toy out on the stairs, and that we're compromising safety for speed. You make a decision that isn't really a big deal now, but you can end up tripping on the toy and falling down and hurting yourself, right? And then we get caught up in this cycle of escalating risk where we start off, there's lots of time pressure, and so we start compromising safety for speed, and then that increases the number and severity of these safety hazards, which leads to more pain and higher task effort, which leads to more time pressure, and we just get caught up in this vicious cycle. And then the risk factors interact with one another. We have things that increase the likelihood of things going wrong and likelihood of mistakes and unexpected behavior, and then things that increase the cost to troubleshoot and repair problems. And so it doesn't take that long before we start heading right for that upper right-hand quadrant, right, where just the pain gets out of control. And so I started looking at aggregating the data and the long-term trends. So I don't have quite enough data. So this is extrapolated from several scattered data sets. But the long-term trends on a software project look kind of like this when you aggregate the idea flow data. So learning is kind of front-loaded at the beginning of a release, and validation is deferred to the end. We have a lot more time we spend, troubleshooting and working out the kinks. And then the baseline friction level keeps rising over time. And then we end up with this problem where the unpredictable work stops fitting in the time box. And the way I did the visualization here, you can see that release 2 is significantly, or release 3 is significantly bigger here. Basically what I did is I did capacity-based slices based on how many hours we're working there, so you can see the fact that the developers had to work twice as long to get that release out the door. So the other thing you notice when you start showing this kind of stuff to management and you say, oh, that white stuff over there, that's the time we get to work on, making progress with features. And then this is all the time that we spend doing all this other stuff of dealing with problems that we're creating for ourselves. And when you start looking at it like this and visualizing these things and measuring the pain, it's pretty scary what we're doing. But since you can't see it, it's easy to say, oh, well, just keep working on features. Go as fast as you can. Work 80 hours a week. It'll be awesome, right? We'll get it done. I'll cheer, right? And this is effects of business pressure. It doesn't matter if you build the Corvette of a project. If management wants to drive your project into the ground, they're going to. So what do we do to solve this problem? Right? I mean, seriously, though, I can't, it's like this is the pattern across our industry. Is we spend all this time going out for drinks after work and bitching about all the problems at our job and that management doesn't understand us and nothing is ever going to change, right? And it's amusing, but this is our life. We cope with all these problems through hanging out and bitch bonding, and it's kind of sad. So at the end of the day, this is the problem that we need to solve. My friend drew this on a napkin, and I was like, this is like the wall of ignorance. So the challenge at an organizational level is decision making is distributed. We don't have the benefit of having all decisions and all knowledge in one brain. We've got people that are making decisions that don't necessarily know all the details of what's going on that they need to know. So if you imagine that our organization was like a robot. We have these different components responsible for different things. And our dev team's down here attached to the pain sensor. We got our management that's in control of the arm. And we got our little fire there, and we're doing a little test. But nothing's happening, right? Well, what if we turn up the fire? Maybe our sensors miscalibrated or something. But the thing that you see in organizations is even when problems are really bad, still nothing changes, right? Because if the feedback loop is broken, we end up burning and nothing gets done. And essentially that's what's going on at the organizational level, is the feedback loop is broken within the organization. So how do we repair the broken feedback loop? And so what I found is we essentially needed a translator to translate all the stuff happening down in the weeds into the language of risk that management understands. And that risk is essentially that bridge language that we can kind of look at things down in the weeds in terms of risk, but you can also aggregate all this stuff to a level of project risk, of our project is going to crash and burn. So I summarize this in terms of 3 different types of risk. So quality risk is the likelihood of unexpected behavior and mistakes and the cost to troubleshoot and repair the problem. So we've been talking about this one. So another one, familiarity risk. So this is driven by the likelihood of working with something unfamiliar and the cost to learn those things. So things like having lots of third-party libraries, complex frameworks, a really large code base, a high turnover rate. All of these things can cause extra learning work. So one of the things I see happening a lot is people get really excited about some new technology that's coming out, or they just have some itch to do some cool technology thing like, let's rewrite everything in Scala. And then they can't find any Scala developers once that one Scala guy leaves the team who knows everything. And this happens a lot where like our technology choices have significant learning curves attached to them. And we have to manage that because it has a cost. We have to manage familiarity on the team. And likewise, if you treat your developers like crap and they end up leaving, it causes massive problems on your project because all your familiarity walks out the door. But this is all stuff that doesn't show up on a balance sheet, right? So assumption risk. So this is driven by the likelihood of making a bad assumption and the cost to correct decisions. So things like bad assumptions about the architecture or design, bad assumptions about customer requirements, and then the longer we delay before making corrections, the more costly it is to do the rework. So a lot of times now in Agile, you have all these stories, and it seems like you can just kind of move them around, and there's no consequences to any of these things. So we create this illusion that moving all this stuff around is free, and it's the product owner's responsibility, but not knowing the direction of the product has significant consequences with respect to rework a lot of times. And so we need some system to get everybody on the same page about what all the costs and risks are when we make decisions kind of across the board and take these things into account. So I started explaining problems in terms of risk to management. So think of it kind of like gambling, in that we save 40 hours in direct costs by leaving the toy on the stairs, but we increase the chance of losing 1,000 hours by 20%, tripping and falling. And nothing is ever guaranteed to happen, which makes this stuff really difficult to explain. But you can explain it pretty reasonably well with a risk model, in that we make decisions to save a few hours here and have side effects that cost several hours. But the nice thing, or I guess not so nice thing, is over the long term, probability wins, right? This is why casinos make money. Is over the long term, making continuous stream of high-risk decisions, you end up in this kind of position where 55% of your time is spent troubleshooting all of these problems. And this is not even unusual. It is really common for a team to spend over half their time dealing with all of this miscellaneous stuff that's hard to measure. So make the problems visible to your manager, and things can start, changing. When, we, like in this case, they skipped, things for data tools because it, was going to take a couple weeks for somebody to build this. And a couple weeks versus that's time I could be building a feature, right? So that's not very high priority, right? But the side effects from not fixing this problem cost them 700 hours per month. And this just seems insane once you make the cost visible. But without the data, it doesn't make sense to people who aren't, in the weeds of software development. So once you have data, you can kind of take responsibility for the problems and ask for support. So in this case, I work on asking for a 3-month improvement trial with dedicated resources for improvement for 1 or 2 developers, depending on the size of your team. And then the dev team will use data to identify the biggest problems and prioritize with management. And I always put prioritize with management in there because it makes them feel important, even though it's kind of almost like a rubber stamping function at that point. And then the thing that I found that actually solidifies the relationship between development and management actually has nothing to do with whether you successfully improve, but everything to do with sharing what's going on. And that if you continuously make the problems visible and help them understand them, it almost doesn't matter whether you're actually making improvements or not. In that managers are really hungry for visibility because they can't see what's going on. That's why managers latch onto metrics so easily. So if you give them good data and help them understand stuff, you'll be their best friend. And just ask, will you help us turn this project around? The one thing that brings people back together is at the end of the day, people tend to care about the success of the project. So you can kind of use that to your advantage as an aligning force in your organization. So broken focus. Make the decision to lead. Now, leadership is not a title bestowed upon you. It's a choice to take responsibility. And we all have that choice to go, I'm going to take responsibility for making these problems visible, for adding them up. So ask, how can I provide better visibility for management? So that's the last reason I have for why improvements efforts fail. So pulling all this together, IdeaFlow Learning Framework is basically a data-driven learning framework for driving improvement. So some of you might notice this looks a whole lot like a control system, and it is. And then essentially, though, it's about improving your decision-making skills as opposed to improving your code. So in the target, this is optimizing for the rate of idea flow. So this is the unambiguous direction that pulls everybody together and going the same way of that sometimes, you'll make decisions that make your life easier and make other people's lives miserable. And having data to objectively define what is difficult for people gives you a way to come together on how can we make this easier for the whole team combined. So target, this is the direction of better. Inputs, these are kind of the constraints that constrain that limit our short-term choices, right? So we can't change our existing familiarity. We have to live with our existing state of the code. We can't snap our fingers and make all of our problems go away. So those are the constraints that we have to live within. And then the output, this is the actual friction in idea flow. So this is the pain signal that we're trying to improve. And then we want to focus on the biggest pain. And then identify the specific patterns of problems that we're running into. And then clarity, understand cause and effect. And awareness, learn strategies to avoid the pain. And so basically, have this data-driven process to identify your biggest problems, break down the causes and understand what they are, and then systematically work on improving decision habits on the team. So it's essentially a process control system for software development and for mastery at the individual level, team level, and I'm actually rolling this up at a supply chain level, and I have a throughput accounting system on top of that to actually go and take all the pain and problems that happen in the weeds and put them on a balance sheet for management to actually start caring about all this stuff. Because with traditional cost accounting, it's like, people are just, one body is the same as another, who cares, right? But the costs of changing people around and all these human problems have a huge effect, and we need to start taking those things into account into business decisions as well. So regardless of my framework, though, in repairing to improve, we need to repair that feedback loop. So target, focusing on the nails. Visibility, installing a pain sensor, even if it's just writing things up on the whiteboard, it can make a really big difference. Clarity, stop making generalizations. Focus on the specific patterns of things going wrong on your project. Awareness, stop and think about those problems that are happening or like your decision making in the moment and how your decisions need to change and how you can influence changes in the moment. And then focus, making the decision to lead and making your problems visible to management. So what I learned when it comes to improvement is the hard part isn't really solving the problems, it's identifying the right problems to solve. And that we're professional problem solvers. We're really good at solving problems. But solving the right problems is challenging. It's really hard to figure out what the problems are that are going to actually make the biggest difference. But putting a little time here, you end up with high leverage improvements, though. So, my original question, why is visibility critical to success? What do you guys think? You feel like you can answer this question now? Did I fail that? So you can solve the right problems. Anybody else have any thoughts? Get management support. Anything else? Say that one more time. So you can make changes to how you're thinking so you don't fall into the same steps or same mistakes repeatedly. So this is kind of what I wrote down is visibility enables the feedback loop. Yeah. Make it so your manager likes you. So is anybody interested in learning more about this? I know it's kind of new stuff with measuring problems in the weeds. So like I mentioned earlier, I just finished my book. It should be out pretty soon, but I'm going to be offering free online training and community support if anybody's interested in doing this. So it'll be Idea Flow Learning Framework, and I'm giving away free ebooks if you're interested in signing up before publishing day. It's newiron.com/tech stuff, and I'll also have online webinars and things like that to give you support and help with that. And then right now, the tools that I was showing in here, you can find on GitHub, idea flow tools. Right now, I just have the prototype version that I've done with my teams, but it's kind of rough. Needs a rewrite. But I'll be working on that in a few months. But you're more than welcome to download and play with the tools. Right now, there's only an IntelliJ plugin, but we're moving all the logic to a server so we can kind of port it over and be able to use this for anything. And then I'm working on building analytic and like business level kind of aggregation and stuff on top of all of this, so we can start actually bridging that gap between management and development and get on the same page with regards to where the pain points are. So if you help me tweet about idea flow, since nobody knows what it is, that would help me out too. But thank you. So do you guys have any questions? We got like 10 minutes left. Yeah.
Thoughts on or maybe some methodology for getting teams to buy into some of these things? Like one of the things focus, like I think it's a really good example of some things that happen. But going to a team member and trying to we're getting someone under you to understand that assessing all these risks, spending all this extra time and methodology. I sense a lot of resistance.
Yeah. That's a good question. So just to quickly summarize, the question was about how do you get your team on board with something like this that clearly is going to take a little more time and which is not necessarily easy. So a couple things is that it's what I found is generally implementing the tools at a development level is extremely awkward at first, but after like a couple weeks, everybody has said it's not a big deal anymore. But it's not necessarily high overhead in terms of time to do. It's hard to remember I'm supposed to hit a button now. So the way I've been selling this at the development level is a couple ways. One of them is if your team is in a lot of pain with regards to business pressure and a lack of understanding, that I sell it as a 1-month trial. Like, let's just give this a shot, gather data for 1 month, and if we aren't able to make the case to management, we'll just bail on the whole effort. And so it has kind of a time limit on it that makes people feel a little comfortable. It's like, okay, I can deal with it for a month if there's hope that things might actually change. And then in my next talk that I'm doing tomorrow is all about making the case to your team and to management and how to actually go through that process with data. So that might be helpful too, because it's there's a huge communication challenge here too. But overhead-wise, I spend a couple hours with the team a week with pair programming and reviewing things, and it's not heavyweight from a time commitment perspective, but it is awkward, kind of in the same way that TDD is really awkward when you first start doing it. But after you do it for a while, you kind of get in the swing of things. And I found that once people get going with it and curiosity kind of takes over, it's people start wanting to do it because it's interesting and they're learning things. And so we do like a 15-minute strategy walk and a reflection walk at the beginning and after task, like planning our strategy and then talking about what happened at the end. And after people start incorporating the feedback into their work, they start wanting the feedback. So once you start using it, and there's a need for it in your process and thinking process, then it's like, oh, I wish I would have recorded that one thing because I would have, had data for this. And since we get in that zone where we're all super focused, and you realize that all this time goes by so quickly, I think that's one of the first things you notice is that when you start seeing things in elapsed time, it's really surprising how long you spend on things. And so the data is fascinating. Does that answer your question? Any other questions? Nobody? Is anybody interested in learning more or giving this a shot or anything? All right, cool. So like I mentioned too, my talk tomorrow is going to be story-based too, but I'm going to tell you about all the times I almost got myself fired trying to make the case to management and causing all kinds of problems in my organization. But what I learned from it and try and help you guys to not make the same mistake. So it should be fun. I'll tell you lots of more ugly truths in my past, but it's the communication challenges are really tough. So I think learning how to speak business is a really good skill for developers to pick up, is just knowing how to communicate their problems to management more effectively so that they, care, right? As opposed to go, just shut up and go code. What do you bother me for, right? All right, well, thank you guys.